Good morning, everyone. Here we are talking about volume. We have already talked about perimeter and area. Looking at the perimeter of regular polygons, we looked at how we can apply that into a formula. So perimeter equals L, which is perimeter equals the length of the sides times the number of the sides. After that, we looked at area, where area equals LW. So area equals the length times width. We've continued on with that formula as we look into volume. So volume, unlike area and perimeter, is a measurement of a 3D object. So an object that takes up 3 dimensions. So volume is a measure. Oh, I'll present here so it's a little bit better for you. I'll get that off because I'm not sure if that's part of the recording. So, volume is a measure of the amount of 3 dimensional space an object occupies. We can also think of it as how much a 3 dimensional space can hold. The most common example for this is how much water can be filled up in a fish tank. Or, yeah, that's usually one of the best examples for what volume actually means. Now, like perimeter, which was a single dimension, just measuring the outside, where we had, say, a yard was 20 meters around a yard, and area was squared because we used 2 dimensions, length and width, so that would give us, say, 600 feet squared in a yard. Volume is cubed, so a unit of measurement to the third or to 3. And that's because we're measuring and multiplying 3 dimensions: length, width, and height. And the units for the volume will always be cubed, so units to the 3. So we have a rule or formula when we are determining volume. So again, volume equals length times width times height, or volume equals LWH. So we multiply the length by the width by the height. So an example here, we have our given measurements. We have a length of 45 centimeters, a width of 25 centimeters, and a height of 15 centimeters. So we multiply 45 by 25 by 15, and that gives us a volume of 16,875 centimeters cubed. Because we took our length, our width, our width, and our height. Now that we have these formulas, we can apply them on our knowledge of algebra. If we have all the information except for one missing piece, we're able to determine what that missing factor is. For example, if we know the area of a rectangle and one side length, but not the other. So, what the volume doesn't show is, say, some examples. So, let me see. I will plug this in and we will go. So, we've seen the example on how to do volume, but let's do an example on how to do a missing factor. So let's say we are given a rectangular prism, and for now, all you have to do is a rectangular prism. There we go. And so we are given a rectangular prism, and we are told that the length is 10 centimeters, the width is 5 centimeters, but we don't know what the height is. All we're told is that the square, or the volume of this rectangular prism is 200 centimeters cubed. Sorry, I had to work that out in my head. So we know that volume is equal to length times width times height. We turn that into V equals LWH, and then we do what we do with all our others when we are given a formula. We write down our knowns. Our known is that we have 200 centimeters cubed. Our length is 10 centimeters. Our width is 5 centimeters. And our height is our unknown, so that will stay the same. Now we put it into this formula. V is equal to 200, which is equal to 10 times 5 times h, our unknown. We want to get this h on its own. So what we do is we divide. We can, first off, we can multiply these two together to give us 50, and we could just divide by 50, and that would give us our answer. Or we can divide them individually. Let's divide them individually for this one. So we divide by 10 to get rid of the 10 on that side. We divide 200 by 10. That gives us 200 divided by 10 is 20. That gives us 5h. We want to get the 5 on our own. So we divide, or we want to get the h on our own. So we divide both sides by 5. That gives us 4 equals h. Now, we can do the same thing if we simply multiply. So we've just figured out that our height is 4 centimeters. But say we did it where we actually multiplied. So we got 10 by 5 by h. If we multiply these two together, because again, if they're right next to each other, that means they're multiplied. We have 200 equals 50h. Divide both sides by 50. We get 4 equals h. So our height is 4 centimeters. Let's try one more. Let's say we have the width and the height. So we know the width is 6 centimeters and the height is 11 centimeters. We don't know the length, but we know that the volume is 132. Again, centimeters cubed. Again, it might work. I just did the calculations quick. So we have our formula, V volume equals length times width times height. Volume is equal to 132 centimeters cubed. We do not know what our length is. We know that our width is 6 centimeters, and we know that our height is 11 centimeters. Now we plug all these in. 132 is equal to length times width times height. Now let's do it. We'll do it both ways again. Let's divide it. We want to get rid of the 6, so divide both sides by 6. 132 divided by 6 is 22. So now we have 22 equals L11. Now normally, again, when we start talking about algebra, we'll say that this, which is the coefficient, goes in front of the variable. But for now, we'll just leave it. But we want to get the L by itself. So we divide both sides by 11, and that gives us our answer of 2 centimeters equals L. So our length is 2 centimeters. Now again, we will get the same answer if we do this. 132 equals L times 6 times 11. If we multiply these two together, that gives us 132 is equal to L66. And if we divide both sides by 66, that gives us 2 equals L. And that's it. We've gone over the difficult part of setting up a formula before and working into an unknown. With adding in a third dimension, we are simply adding in one extra step as we move through. There we go. We're putting in one extra step as we move through